Hey guys, so today we're going to talk about solving absolute value inequalities. So here's an inequality. Absolute value of x is less than 6. That means our distance from 0 has to be less than 6 units. So thinking about a number line, distance from 0, absolute value being less than 6 means it could be anywhere in between 0 and positive 6, or even 0 and negative 6. So from negative 6 to positive 6, all of those different numbers satisfy our inequality. So we would say x has to be greater than negative 6 and x is less than 6. And we prefer to write it as a compound inequality. Negative 6 is less than x, which is less than 6. So this is how I'll want your answer. So again, absolute value of x is less than 4. This time, thinking about it on a number line, we know that it has to be between 0 and positive 4, or between negative 4 and 0. So we can rewrite that as two separate inequalities, but again, I want to get in the habit of writing it from negative 4 to positive 4. So negative 4 is less than x, less than 4. And then there would be your accurate graph. This graph up here was just to help visualize what would satisfy that inequality. Here's your actual graphed solution. Okay, let's change our inequality sign. Absolute value of x is greater than 7. That means now that my distance from 0 has to be 7 or bigger. So we know that it would have to be here at 7, or anything to the right, and negative 7, and anything to the left is going to give us a distance bigger than 7. So we would have x is less than negative 7, or x is greater than positive 7. And then I just incorporated the actual open circles for my less than or greater than sign. Okay, here is an inequality with one step, so we obviously need to subtract that 7.4 to get absolute value of x is less than or equal to 2.4. So less than or equal to 2.4, hopefully we know is going to be greater than or equal to negative 2.4, and less than or equal to positive 2.4. Written as a compound inequality, it looks like that. And there would be your graph. Okay, solve and graph this one. Again, get that absolute value all by itself, so multiply by 4. Doing that would give you absolute value of x is greater than 8. So we know x has to be less than negative 8, or x has to be greater than 8. If you're having a hard time getting from this step to this step, go ahead and draw that graph and visualize where is my distance greater than 8. And there is your graph then. Okay, I want you guys to solve and graph. Obviously, you can't graph on here, so just give your solution on here and then practice graphing on your own. Don't forget, when you divide by a negative, what do you have to do that sign? Okay, so hopefully you've seen a pattern. We're going to look at these two rules for solving absolute value inequalities. If you have a less than sign, your solution will always be this compound inequality. So negative a less than x less than a. If you have an absolute value greater than a constant, your solution will be x is less than the negative version, or x is greater than the positive version. So these two rules you'll want to write down and then have next to you when you solve any of your equations, so you know, should my solution look like this, or should my solution look like this? Okay, and one last example, actually 2 more examples. Here we have one step inside of our absolute value bar, so we need to write our two equations. So x plus 7 is less than negative 3, or x plus 7 is greater than 3. That's just like our equations earlier in the lesson. So subtract 7, x is less than negative 10. If you subtract 7 over here, x is greater than negative 4. Graphically, it looks something like that. Remember, or graphs will always have arrows going in the opposite direction. And last, if we have absolute value of x is less than or equal to negative 2, remember absolute value talks about distance from 0. Our distance can never be a negative number. So this absolute value being less than a negative number would be no solution.